Welcome back to AI.Code.Cast. Today, we're going to be taking a deep dive into a classic coding problem that shows up all the time in technical interviews. It's finding three consecutive odd numbers in an array.
Okay.
It's one of those problems that, at first glance, it might seem pretty simple, but there's actually a lot more to it than meets the eye.
Yeah, it's pretty fascinating.
Yeah.
Because, you can solve it in a very straightforward way, but the fun really begins when you start exploring more efficient and elegant approaches.
Yeah, that's a really good point. It's all about understanding the trade-offs
Yeah.
and choosing the right tool for the job.
Okay.
So before we jump into, all the different solutions, can you maybe take a moment and explain the problem for our listeners?
Sure. So imagine you're given a list of numbers, right?
Okay.
In coding, we call it an array.
Okay.
And your task is to figure out if there are three consecutive odd numbers
So,
hiding somewhere in that list. So, for example, if the array is 2, 5, 1, 7, 9, and 4,
yeah.
you would see that, yep, we have 5, 7, and 9.
Right.
Yeah.
Three consecutive odd numbers.
Yay.
Perfect. So it's a little treasure hunt within a list of numbers.
Exactly.
Now, if you were to give me a hint to solve this problem, what would that be?
Well, think about how you would approach this problem manually.
Right.
You'd probably start at the beginning of the list.
Okay.
Check each number.
Right.
If you find an odd number, you get a little bit excited, and then you check the next one.
Yeah.
If it's also odd, you're like, oh, this is looking good.
Right.
And then the third one, if that one is also odd, then bingo.
Yes.
We found our consecutive odd triplet.
Okay, yeah, that makes perfect sense. It's like you're following a trail of breadcrumbs
Exactly.
to get to your destination.
Yeah.
So if we were to kind of translate that thought process into code,
Yeah.
we would basically, go through the array step by step, right?
Exactly. And this is where we encounter what is often referred to as the brute force approach.
Right.
So this is like using a hammer to crack a nut.
Okay.
It gets the job done, but it may not be the most refined technique.
Okay, I like that analogy.
Yeah.
So let's unpack this brute force method. How would we actually implement it in code?
So it's surprisingly straightforward.
Okay.
We'd use a loop to iterate through each number in the array.
Right.
For every number, we'd check if it's odd.
Okay.
If it is, we then check if the next number is also odd, and so on, until we've checked three consecutive numbers.
So it's like saying, okay, this number is odd. Let's peek at the next one and the one after that and see if, our odd streak continues.
Exactly.
And if it does, we find three in a row, we celebrate.
Precisely. We would then return true.
Okay.
Which in code basically means, yes, we found it.
Right.
But what if we don't find three consecutive odd numbers?
I guess in that case, we just keep going.
Yeah.
Until we get to the end of the array.
Yeah.
And if we still haven't found, our special little triplet, then I guess we have to kind of admit defeat.
That's right. We would return false to signal that the search was unsuccessful.
Got it. Okay. Now let's talk about the efficiency of this brute force method. So in computer science, we often talk about this thing called time complexity, right?
Yes.
Can you maybe explain what that means and how it applies here?
Absolutely. So time complexity is essentially a way to describe how the runtime of an algorithm grows as the input size increases.
Okay.
So imagine you have a small array with 10 numbers.
Right.
Versus a massive array with a million numbers.
Right.
How much longer would the brute force approach take for the larger array?
Okay.
That's what time complexity helps us quantify.
Got it. So in simple terms, it's like saying, if I give you a bigger haystack, how much longer will it take you to find the needle?
Exactly.
I like that.
Yeah. So in the case of brute force, the time complexity is what we call O of n.
Okay.
Where n represents the number of elements in the array. And this basically means that the time it takes to run the algorithm increases linearly with the size of the array.
That makes sense. So if we double the size of the array, it'll take us, roughly double the time to find the solution.
Yeah.
Now, besides time complexity, we also talk about this thing called space complexity, right?
Yes.
What does that refer to?
So space complexity focuses on how much additional memory an algorithm uses.
Okay.
Think of it as the amount of scratch paper you need to solve a problem.
Got it.
Some algorithms require a lot of extra space, while others can work very efficiently with just a few variables.
So it's like asking, how many sticky notes will you need to keep track of everything while you're solving this puzzle?
That's a great analogy.
Okay, cool.
So in the case of our brute force approach, the space complexity is what we call O of 1.
Okay.
Meaning It uses a constant amount of extra space.
Okay.
We're just storing a few variables for our loop-in checks, regardless of how large the array gets.
Got it. So this brute force method seems pretty simple to, you know, implement.
Yeah.
But are there any potential pitfalls or things to watch out for?
Well, one thing to keep in mind is that brute force can be quite inefficient for very large arrays
Okay.
because we're checking every possible triplet.
Right.
The runtime can grow significantly as the array size increases.
Yeah.
So it might be fine for small data sets, but if you're dealing with millions, billions of numbers,
Right. Yeah.
you definitely want to explore more optimized approaches.
So it's a good starting point,
Yeah.
but maybe not the best choice for, massive data sets.
Exactly.
Okay, so we've got like a good understanding of the problem
Right.
and this basic brute force solution.
Yeah.
Are there any hints you can give us to kind of get us thinking about other approaches?
Here's a hint. Instead of checking every single triplet, think about whether there's a way to keep track of your progress as you go through the array. Can you use a variable to store information about whether you're on a streak of odd numbers?
Ooh, that's a clever idea. So instead of like repeatedly looking at groups of 3,
Yeah.
maybe we can use a variable to keep track of how many consecutive odd numbers we've encountered so far.
Exactly.
And if we hit 3, we know we've found our solution.
Yeah. That's exactly the kind of thinking we're looking for.
Right.
So let's call this the counting approach, right?
Okay.
Instead of examining every possible triplet, we're going to be using a counter
Okay.
to keep track of consecutive odd numbers
Okay.
as we move through the array.
Okay. I'm really liking where this is going. It's like we're playing a game
Yeah.
and we're keeping score of like our odd number streak.
Exactly. So we're going to start with our counter set to 0,
Okay.
and then we'll begin our journey through the array, examining each number one by one.
Okay.
If we encounter an odd number, we increment our counter. Yay! Our streak continues.
Right.
But if we hit an even number,
I bet that resets our counter back to 0.
you got it.
Like our streak is broken.
The even number acts like a reset button,
Okay.
forcing us to start our count afresh.
Right.
But the moment our counter reaches 3, we know we found those 3 consecutive odd numbers.
Yes.
And we can triumphantly declare victory.
I love how like intuitive this approach feels.
Yeah.
It's like we're kind of replacing these like complex calculations with just a simple counting mechanism.
Yeah.
To make sure I'm fully grasping it, can we maybe walk through an example together?
Absolutely. So let's take that array, 1, 3, 5, 2, 7, 9, 11.
Okay.
Same as we used before.
Right.
We start at the first element, which is 1, an odd number.
Okay.
So our counter goes up to 1.
1 point for Team Odd.
Next we have 3, another odd number, counter goes up to 2.
2 in a row. This is getting exciting.
We're on a roll,
Yeah.
and then bam, we hit 5, a third consecutive odd number.
Yes.
Our counter reaches 3, and we found our triplet.
We did it, and we didn't even have to look at the rest of the array.
Precisely.
Yep.
And this illustrates a key advantage of the counting approach.
Okay.
It can be much faster than brute force.
Right.
Because it doesn't necessarily have to examine every single element in the array.
That makes sense.
Yeah.
Okay, so now I'm curious about the time and space complexity of this method.
Right?
How does it kind of like stack up against brute force?
So in terms of time complexity, it's still O of n, just like brute force.
Okay.
In the worst case scenario where the triplet is at the very end of the array or doesn't exist at all,
Right.
we would have to go through the entire array.
Right. But like you said, it often finds the solution much faster in practice.
Exactly. And the
Yeah.
space complexity, it's O of 1, just like brute force.
Okay.
We're only using a single variable to store our counter,
Okay.
regardless of the array size.
So it's efficient, it's easy to understand,
Yeah.
and uses very minimal extra space.
Right.
This counting approach is shaping up to be a strong contender
It's a very handy technique. Yeah.
to have in your coding toolbox.
Okay.
And the principle behind it, using a counter to track a pattern, applies to many other problem-solving scenarios.
Okay, that's cool. Now, before we move on, I want to play devil's advocate for a moment. What if the consecutive odd numbers weren't so nicely bunched together at the beginning of the array?
Okay.
Would this counting approach still be efficient?
That's a great question. You're right. So if the triplet were located near the ends of the array,
Right.
the counting approach wouldn't save us that much time
Okay.
compared to brute force because we'd still end up going through most of the elements.
So it's not like a silver bullet.
Yeah.
There are scenarios where brute force might actually be just as fast,
Exactly.
even though it seems, less elegant.
Exactly. That's why understanding the trade-offs of different algorithms is so important.
Okay.
There's often no single best solution. It all depends on the specific characteristics of the problem you're trying to solve. Right. Right. That makes sense. All right. I think we've thoroughly explored this counting approach,
Yeah.
but you hinted earlier that there might be even more ways to tackle this problem.
Yeah.
Are there any other clues you can share to guide us towards the next solution?
Here's a hint. Think about the mathematical properties of odd and even numbers,
Okay.
particularly when it comes to multiplication.
Okay.
Is there a shortcut we can use to determine if three numbers are all odd
Hmm.
without checking each one individually?
Ooh, that's interesting. Now you got my math brain firing up.
Hmm.
So if I'm thinking about multiplication and odd and even numbers, well, I know that multiplying any number by an even number results in an even number.
Yes.
So if the product of three numbers is odd, it means all three of them must be odd, right?
You nailed it.
Okay.
And that's the key to our next approach, the product of three numbers method.
This product of three numbers approach, it sounds incredibly clever. It feels like we're taking a shortcut through the problem.
Yeah.
Using a bit of mathematical wizardry.
That's a great way to put it. Yeah, so instead of individually checking the oddness of each number,
Right.
we can kind of exploit this property of multiplication
Right
to our advantage.
Okay. So walk me through how we'd actually implement this method in code.
So it's actually quite similar to our previous approaches. We'd
Yeah.
still use a loop to go through the array,
Okay.
but this time for each element, we'd calculate the product
Okay.
of that element, the one next to it, and the one after that.
So for each position in the array, we're multiplying a little triplet
Exactly.
of numbers together.
Exactly.
Okay.
And then we ask that crucial question, is this product odd?
Right.
And if it is, we know for sure
Yeah.
that all three numbers in that triplet
Right.
must be odd.
That's the moment of truth.
Yes.
If the product is odd, we've struck gold, we found our consecutive odd numbers, and we can return true.
You got it.
Okay.
But if the product is even, we know at least one of those numbers must be even.
Right.
So our search continues.
Okay.
We move on to the next triplet
Right.
and repeat the process.
Okay, this method seems super efficient.
Yeah.
But are there any, potential pitfalls we should be aware of? What if, the numbers in the array are huge
Yeah.
and multiplying them together results in some number that's, too big
Right.
for the computer to handle?
That's a great question. So you're thinking about a concept called integer overflow,
Okay.
which can indeed happen when we work with multiplication
Right.
and very large numbers.
So how do we avoid that problem?
So in most cases, the problem statement itself
Okay.
will provide constraints on the size of the numbers in the array.
Well,
So if we know the numbers will be within a certain range,
right.
we can be confident that overflow won't be an issue.
That makes sense.
Yeah.
And if the numbers could potentially be, gigantic
And we might need to use a different data type that can handle larger numbers or implement some checks to prevent overflow.
Okay.
But for the sake of this problem, let's just assume the numbers are within a reasonable range.
Okay, that addresses my concern.
Mm-hmm.
Now, I'm curious about the efficiency of this product of three numbers approach.
Okay.
How does its time and space complexity compare to the other methods we've discussed?
So the time complexity is still O of n,
Okay.
just like brute force and counting methods.
Okay.
In the worst case scenario, we still need to go through the entire array.
Right, but in practice, we might find the solution much faster if the triplet appears early in the array.
Exactly.
Okay, cool.
And the space complexity remains a beautiful O of 1.
Nice, okay.
We're only using a handful of variables
Yeah.
to store the product and our loop index,
Okay.
regardless of the array size.
Okay, so this method is efficient, leverages a clever mathematical trick, and doesn't require a lot of extra memory.
Yep.
Sounds like a winner to me.
Mm-hmm.
But before we, declare this the champion, are there any downsides or trade-offs we should consider?
Well, one thing to note is that this approach might not be as immediately intuitive as the counting approach.
Okay.
It requires a bit more thought to understand why it works.
Yeah, it's true. The logic is a bit more abstract,
Yeah.
but I think that's part of what makes it so elegant. It's like a beautiful example of how mathematical thinking
Right.
can lead to more efficient code.
Absolutely. It's a reminder that sometimes the most satisfying solutions
Yeah.
are the ones that make you think outside the box.
Right. So we've now explored three distinct approaches to finding those elusive three consecutive odd numbers in an array.
All right.
We started with the straightforward brute force method.
Yeah.
Then we discovered the elegant counting approach. And finally, we unveiled the mathematically savvy product of three numbers method.
Yeah.
Each approach kind of has its own strengths and weaknesses, right?
Precisely.
Yeah.
Brute force is simple to understand and implement,
Yeah.
but it can be inefficient for large arrays.
Right.
The counting approach is efficient and intuitive,
Yeah.
but might not always be the fastest, depending on the location of the triplet.
All right.
And the product of three numbers method is elegant, leverages a clever shortcut,
Right.
but might require a bit more thought to grasp.
Right. It's like having a toolbox
Yeah.
with all these different tools for different jobs.
Yep.
The key is like understanding which tool is best suited for the task at hand.
Absolutely.
Now, if you had to choose like a favorite
Okay.
for this particular problem, which one would it be?
For this specific problem, I'm quite fond of the counting approach because it strikes a nice balance
Okay.
between efficiency, simplicity, and clarity.
Okay.
It's easy to explain, it avoids any unnecessary computations, and it embodies a pattern that can be applied to many other coding challenges.
Okay, yeah, I can see why you'd appreciate that. But I have to admit that product of three numbers method, with its touch of mathematical elegance, has a special place in my heart.
Yeah, for sure.
It's just it's a nice reminder that sometimes the most creative solutions come from looking at a problem from a different angle.
I completely agreed. It's all about expanding our problem-solving toolkit and embracing different ways of thinking.
Right. And on that note, I think it's time to wrap up this deep dive. We've explored the problem, we dissected various solutions, and hopefully sparked some algorithmic inspiration along the way.
It's been a pleasure delving into this challenge with you and all of our listeners. And remember, the journey of exploring algorithms is just as rewarding as finding the solution.
Absolutely. A big thank you to all our listeners for joining us on this coding adventure.
Yes, thank you.
And if you enjoyed this episode, be sure to subscribe to AI.Code.Cast for more deep dives into the fascinating world of algorithms. Until next time, happy coding.